Okay, step one of locating the center of your fourth axis. We're gonna start with you go ahead and put the fourth axis in, and we're gonna snug up this back bolt. What we wanna do is just allow this to pivot so that we can square it to the table first. Okay, and what I've done here is I've installed this Noga magnetic base and a 1/10 indicator. I'm gonna go ahead and use this to jog it back and forth and get this fourth axis square to the table. Okay, now we got it pretty well dialed in. We're about 3 9/10 there, and probably about 50 millionths past that on the far side, over 9 inches. So that's really good. There's a little low spot in the middle, but we got our bolts here and there, just about as tight as we can get them. You want those really tight. I have seen these things move when you're really ripping with the face mill or something. Okay, now I have the Noga base here, and I'm just gonna dial in. This is my 0-point system from Orange Vice. You don't have to have this, but basically I'm just zeroing in the center of my adapter for my fixtures. Okay, we got this dialed in. We're within about 1 thou. I think this hole's not entirely round, so that's as good as I can get it. Okay, now we have our 0-point system centered. We have I made an adapter, our 5th axis vise, so everything is centered on the 4th axis, and we have a piece of material clamped in. Okay, go ahead and jog it all the way to the front. Okay, so now we have where this is actually, our A is 0. Because there's a clamped in here, you can actually see the deviation in the material. But so it was at 0 at that end, and then it should be at 0 at this end. Keep going. Okay. So yeah, there we go. So we're 0 at both ends. So now on the control, we come over here, and we're just going to 0 our A axis. So now at least we can go back to where the part is level. Okay, so now what I've done is I've gone ahead and kind of just measured from the table roughly to the center of my rotary, and then however you zero your Z. I basically eyeball or guesstimate what my Z is going to be to get it close, right? It's going to be off. It could be off 1/8 or 1/4 or however much you're off. Here at MDI, I'm going to be using G59 as my coordinate system, and I just do G0, A0 to make sure it's flat. I'm using tool 6, M6, and then I call the height offset for tool 6, and then I'm going to feed to 0.5 inches. I'm feeding to 0.5 inches because my material is 1 inch thick. So ideally what we want this to do is feed down to roughly the top of our material. Okay, so here we have, I'm using G59 for my rotary axis, and then G0, A0 just to make sure it's flat. Tool 6, M6, I'm going to be using tool 6. And I call a height set, G43 of that tool number, H6. And then I'm going to feed to 0.75 at 50 inches. So the reason I'm feeding to 0.75 is the stock I'm using is 1.5 inches. So half of the stock, right? So if the center of our 4th axis is right here, we want to be at the top of our stock. Okay, so now we're going to be using G59 as our rotary coordinate system. G0, A0 just to make sure it's flat. We're calling tool 6, and then a height offset for tool 6. We're going to feed to 0.74 at 50 inches. So the reason 0.74 is because this is 1.5 inch material. So half would be 3/4, 0.75, right? Well, we want it to go a little bit lower than the top of the material to take a cut. So we're going to go ahead and run that. This is going to feed. Should stop about the top of the material. Okay. And then we're going to go ahead and jog this. Over the top. Okay. And then we're going to rotate 180 degrees. And you see we are at G59 180. We're going to draw it across the top of this. Okay. Going to stop it. Okay, now if we were to measure this from top to bottom, it should be double what 0.74 is, so 1.48. So we're going to use some Michitoyo Quantum mics. I'm going to have to So we're at 1.4834. So what we want to do is we're 3 4/10 off, right? So we want to cut that number in half, and that's how much we're going to subtract to lower it down. So half of that is going to be 1 7/10. So we're going to come over here to our G59Z, and we're going to do minus 0.0017. Enter, right? Okay, so our Z value just changed 1 7/10. So what we're going to do is we're going to go to our program here, and we're going to modify this to Z 0.73. We're going to go down 10th, right? And we're going to rerun it. Okay, so now we should be at what? 1.46. We went double 7.3, right? So let's check it here. And it looks like we're about what? About 5/10 under. So we could go ahead and do now is we can raise it half that, right? So 2.5/10. Well, unfortunately, Haas, you can only do tenths. You can't do millions. So we're going to raise that. We're going to go plus 0.0002. Okay, that's two decimal points. 0.0002. And basically, I mean, that we can leave it at that, and our parts will be within a half a thou, which is pretty good. I mean, the tool setter is only repeatable within 2/10. So I mean, but the more accurate you can get it from the start, the more accurate the parts are going to be. But so now that we know, right now we know that this is perfectly centered top to bottom. So what you do, go ahead and jog this 90 degrees. And I would use my probe to probe either side of this and find the center. You could use an edge finder, you could use a Heimer, you could use whatever you want. But this is 100% center with our y-axis now. So if you go ahead and probe this, your y will be centered and then your z will be set. And then usually to set my x, I'll touch off the face of the jaw with my probe. My coordinate system is usually back here, but I probe this just because this is the most important part of, or you could probe this, So now we're gonna go ahead and just do a probing cycle and probe I like to probe the face of the vise, just to make sure that, we don't crash into our part here. So that's that. Okay, and then we're gonna go ahead and probe these positions. I said you could probe, you could do an edge finder, you could do a Heimer, whatever you want. I go ahead and probe that to find the center of that part. And we know that that is the center because we machined it centered. Now we have X, Y, and Z set on our fourth axis.